matrix. Okay, vectors is like a single column matrix. So we have learned about matrix. It is like this, right? But vectors is one column only. So one column, two rows. So the first coordinate, the first value you see here is the x value. Okay, the second value you see here is your y value. So vectors is like a column matrix, one column only. That's why you learn matrix before vectors. Okay, so first thing first, you learn in physics that a scalar, okay, a scalar quantity is a quantity that has only what? Magnitude. Okay, but a vector quantity,
Kieran, can you pass one hard copy though?
for vectors, right? Okay, a vector quantity is something that has both magnitude and direction. So very soon you will learn that if we write vectors, right, there is always an arrow above it, an arrowhead that points in a certain direction. So this tells you to move from origin to A. So in your coordinate geometry plane, right, if I say A is at 3, 5. Okay, my coordinate A is at 3, 5. To move from O to A, so this is my vector OA. To move from O to A, I need to move 3 units to the right. Okay, this one tells me X direction, move how many units. So 3 units to the right, and then I move up by 5 units. So 3, 5 means moving 3 steps here and then go up by 5 steps. So this is moving from O to A. So if I have another point B, example maybe here, I say it's minus 2, okay, minus 1. So this is point B, negative 2, negative 1. So if I want to write the vector OB, I'm moving from O to B now. So I need to move in the X direction 2 units to the left. So when I write minus 2 units. It's going minus 2. Okay, and then I need to move down by 1 unit, so minus 1. So the number tells you how to move your vectors. Okay, so it has a direction. The direction very important. So a vector can be represented by a directed line segment with its direction indicated by an arrow button, arrowhead, sorry. So arrow AB represents the vector with an initial point A, okay, and a terminal, or we can say final, okay, point B. Okay, sometimes instead of writing vectors as A moving to B, example like that, then we say, okay, let this vector be represented by A. Okay, and then they put a curly tail at the bottom. Because A is algebra. But if you put a curly tail at the bottom, it becomes a vector already. So it's just a symbol for it. So we will just write this to represent vector. Or if you are able to bold it, like you go and write it until as if it's like bold, then you can bold it lah. But when I type, I can bold it, but when you draw, you cannot. So you represent by a curly tail. Or we call this thing braces also. Okay, this thing that you see below it is called a braces or curly tail. When it is a vector, so we will use a letter, then with a braces at the bottom. But they will tell you, the question will say, oh, A to B, Then they put a C with a braces below. You know this means vector. Okay, not algebra.
So AB arrow on top is same as A.
Yes. So they will write like that. AB is represented by this. Okay. So I have just told you that vector is usually like a column matrix. So 1 means you move 1 to the right. Okay, 2 means you move 2 units upward. So up is positive, down is negative. Right is positive, left is negative. Like your XY axis like that. Okay, so if they start to draw this line, okay, it means they want you to find the magnitude. Magnitude is like asking you to find the length. So you imagine just now, I gave you this. Okay, if I want you to find the magnitude of the vector OA, this one, what do you think I want you to find? The length of OA. So you use Pythagoras theorem. So just now we know that this one is moving 3 units. So the X is 3. Okay, this one is moving 5 units. So the Y is 5. So can you see this is a square plus B square? So you take a square root. So to find magnitude is to find the length, and it is using Pythagoras theorem. So whatever this value is, you go and square it. Whatever this value is, you go and square it. Add them up and take a square root. So this is the formula for finding magnitude. Okay, later when we do example, it will be clearer. Okay, because they are telling you every important thing in this one page. Okay, so if I tell you 2 vectors are equal, for example, AB is 3, 5. Okay, the other vector is DC, no, maybe CD is also 3, 5. I can say they are equal because they are in the same direction. Okay, and they have the same magnitude. So they must fulfill 2 things for 2 vectors to be equal. Okay, if I were to draw it out, it will disappear. Okay, next, they are referring to G. So this one now. So G is equivalent to H, not H, negative H. And then what is the matrix? The column matrix that represent this vector?
2, 1, 3, 1.
Any unit I move to the right? No, so 0. And I just go up by 3 units. So it's 0, 3. So I never move left or never move right. So I'm at the same position. Jamil and Sailesh, this one is the beginning of vector. Don't play. Yeah, you laugh and you say something in your eye. Okay, last one is M. M is this one. So we can say is, yes, negative K with the curly braces or the curly tail. And then what is the, okay, don't answer, all don't answer. Sailesh, what is the column matrix that represents M? You see? Jamil? Yeah, but what is the column matrix that represents it? If I'm moving from here to here, how many units did I move to the right and upward? How many units? X direction 2, so this one is 2. Y direction go 1. So your column matrix is 2, 1. So move 2 units to the right, go upward by 1. Okay, now they want magnitude. So magnitude, I don't care the direction because magnitude is length, right? So if I want to find PQ, this one, this is the column matrix. I want to find the magnitude, means I square the x. Okay, and then I square the y, and then I take a square root. So it's equal to 3 units.
Isn't it just Pythagoras?
Which one? Yeah, it's just Pythagoras theorem. So what is this also equal to? It's also equal to F magnitude with the curly braces. Because just now we already state that it's equal. Okay, now we look at G. G is the same thing as negative H. Remember, you need the curly tail. You drop out the curly tail, it means algebra. Okay, so if it's vectors, must have that braces at the bottom.
What do you mean by magnitude?
Magnitude means the length. So just now, when we have M, right? I want to know the length of this line. But I know this one is 3 units. I know this one is, no, 2 and 1, sorry. So this one is 2 units. This one is 1 unit. So to find this length, I use Pythagoras theorem. A square plus B square equals to C square. So you take a square root. So this one will give you the length of M. So you are basically squaring the X and the Y. Okay, Okay, Krishvan, how do I find the magnitude of G? This one. Zero, zero. Yeah, 0, 3, yes. But how to find magnitude? 0 square plus 3 square, correct? So it's just 3 units. Is there anything else is equal to? Don't have already, right? Okay, then this one is extra. Not essential. Oh, in fact, is it equal to the DE? It is, no, opposite. It's opposite. So unless I put ED. Okay, so this is a rough idea. You must know how to write down the matrix, when to have curly tail, how to find magnitude. Okay, this is the basic idea. You don't know, then behind all don't know. So better pay attention. Silas, you go there, right? Jamil learn nothing, you know. Then you also never learn anything. That's why cannot sit together. You all don't know what's good for yourself. Who is Elaine?
She's very good at proving her point.
Really? Okay, very good.
She proved that her father needs to be taken care of because he got a second stroke.
Yeah, so I've proven that Silas needs to be taken care of. See, you eat pencil. Okay, this one. How to find magnitude of this vector? So,
Square root 3 square negative.
okay, so square the x and square the y. Silas, you copying or not?
Equal to
What?
5.
Okay, so when we find magnitude, square the x
5.
and then square the y. So we actually wanted to include this in WA2, just the 5.1, writing vectors and finding magnitude, because it's supposed to help you. But I think we decided not to, because no time. Okay, so the length is 5 units. Okay, they say, can you find the magnitude of the vector? No, find the value of A if the magnitude of the vector is 13. Okay, so what you can do is go and find the magnitude first. So A square plus 12 square, square root. They are saying that this thing is equals to 13. So what we can do is we want to solve for the A. So we take square on both sides. When you square both sides, the square root disappears. So we are left with A square plus 144. This is 169. So A square is 25. Or negative 5. When you take square root, there's always two answers, 1 plus, 1 minus. So that's why they gave you a hint, find the values of A.
Maybe we reject the minus.
Don't reject, it's one of the possible answer.
It's not minus, so like 30 seconds left.
Wait. We are waiting.
How?
You 13 square minus 12 square, that is correct.
Oh, can. Okay, if you want to 13 square minus 12 square, then take square root also can. Okay, so this is the basics of Pythagoras theorem. Why? Okay, since it's like few seconds.
Yes, this one. Yes.
Oh, sorry. Okay, this one. So, assuming this is A and this is B, if I want to draw A plus B, let me start from A. A is 3 box to the right. Okay, B is 3 box upwards. Okay, too much. 3 box upwards. So, A plus B is the diagonal here. Yes. Can we what? You can use freehand or ruler. We are not so particular. Okay? So the line that you are essentially drawing is this one. This is the A plus B. Okay, next is they want A minus B. So A is 3 units. Okay, to the right. And then minus B, instead of upward, it goes downwards now. Minus B is the opposite direction. So go downward by 3 units, minus B. So actually what they want you to draw is this diagonal here. A minus B. So this is the answer they want. Okay, it is how you should be moving. So you need to gauge your space. Whether you are moving up or down, then you see where you draw. If it's positive, it goes like that. Like that. Opposite. Yes. Down. Y is going down. So if this one I go opposite, if it's minus A, there is opposite direction, like that. Going right, left. This one going right, opposite. Yeah. How do the? Okay, you see, they asked me to move A first, so it's going this direction 3 units. Because A is moving 3 units to the right. The red one is the final one. It's called your resultant vector. You're in physics learn this, right? Like when you move this direction, then next, where is the resultant? Where is your ultimate movement?
So the arrow direction doesn't matter.
Actually, these two you don't draw, never mind. This is the final one they want to see. This is the working to get there. Okay? So it's like topo, right? They tell you, oh, you move in this direction 3 steps, then that direction 3 steps. Your ultimate goal is your movement. Where do you move from the start to the end point? So what I'm interested is the red one only. The black one is the working. Even if you don't draw, it's fine. Okay? So let's look at this one. 2A plus B. So instead of moving 3 units to the right, I need to move 6 units now. So 6 units. 3, 6. So this is 2A. Moving 6 units. 2 blocks of A. And then plus B. So I move upward by 3 units. So this is the resultant that I should get, moving from here to there. So this is 2A plus B. This is what I need to see. Yes. Because I started from here, it must end here. Initial and final. So you must always start from your initial and end at your final. Yeah. Yeah. Correct. Yes. This one worth 13 marks? No? No, O level don't ask you to draw, ever. They will ask you to find the vector. They won't ask you to draw, but they will ask you to find the vector. So this drawing is to help you understand how to find the final one. Can. Okay, next one, 2A. 2A is 6 units to the right. And then I know I need to move downwards by 9 units. So I need to plan my space so that I have enough. So I will anticipate that I should start here 6 units. So I decided that this one must start here. So this is my initial point. I just estimate. It can start somewhere else. Okay, and then I want to move downward 9 boxes. So 1B, 2B, 3B. Just make sure you have enough space to move downward by 9. Your initial point may be lower than mine, it doesn't matter. Just make sure that your final one is similar. How it moves are good to have, so that you know where you are ending at. I means initial. This one is your final end point. So you know that moving 2A minus 3B will end you at that point there, the final point there. So this is the final point. Justin and Jamil, you're drawing or not? You all stare at the screen, you'll move on its own, huh? Where's your notes? Now bring. Do you bring your notes? Then use the soft copy in Google Classroom. Vectors. Okay, next one is B minus A. So B is going upward 3 units. So I do B first. B is going upward 3 units. And then they say minus A. A is moving to the right 3 units. Minus A is moving to the left 3 units. So I move to the left 3 units. So this is my initial point. I'm ending here. So this is my movement. B minus A. So I move B first, then I do a minus A. So I started from here and here. So this is my initial and final. Yeah.
How do people count fireworks?
Firework launchers. I don't know why. Why that question?
Because there's people making fireworks.
Yeah,
What profession is
we can find out.
There's supposed to be a teacher scaring me.
I don't make fireworks, so I don't know. Okay, anyway, A represents 3 units to the right? So 2.5 of A means 7.5 units to the right. So I'm going to move 7.5 units. Cannot use weight. Okay, so 2, 4, 6, 7.5. Okay, so this is 2.5A. And then I want to move 9 units upwards. So 3, 3, 3. I end up being here. 3b. So 9 units upwards. So my final resultant vector is this one. So 2.5a plus 3b. That's all. Nine units up. 3, 6, 9. Yeah, correct. 9 box upward. The way Jamil is staring into the screen is very suspicious.
You wish your husband stares at you like the way Jamil stares at the screen. This song last 5 minutes, by the way.
Already? No, now got 7. Okay, so the drawing part shouldn't be difficult. It's just an exercise that O level won't test you like that. They have never tested drawing for vectors before. Okay, so if you all can still remember, let's say I say moving from point A to point B is represented by 1, 2. Okay, ready? It means if A is here, I will move 1 unit in the X direction. 1 unit. Okay? And I will move 2 units in the positive Y direction to finally reach B. So vectors tell me how to move from A to B, 1 unit and then 2 units upwards. So this vector that you see tells you how many steps to move in the X direction and in the Y. If I want to find the magnitude, this one means finding magnitude or distance. It is using Pythagoras theorem. So actually it's 1 square plus 2 square square root, because this is B, this is A, this is C. So actually it is A square plus B square. So what we do is take the X coordinate here, you square it, add it to the Y coordinate here and you square it, followed by a square root. So when you are finding the length of AB, you are finding Pythagoras theorem to find the distance. Okay, so this is the second thing that we have learned. Okay, next thing. Okay, next thing, when we represent vectors with a letter, we must use the curly tail. This thing we call it the curly tail, or sometimes we call it the braces. So this will represent vector instead of algebra. So make sure you all know how to represent vectors. Must have that curly tail. No curly tail, then wrong already, yeah? Okay, so these were the 3 main things that we learned previous lesson. Let's look at how to draw our page. Fine. So first thing first, this is the vector D and this is the vector C. When they ask you to draw D plus C, we need to follow the direction. So assuming this is my D. Oh, I cannot draw here. I must draw lower. Assuming this is D. Yes. Okay, this one, can I leave you to go and draw? Go back and draw on your own. D plus C, just like that. This one is just 1 rectangle. So if it's 2C, it becomes 2 rectangle. So it's just like that, okay? Sorry, this one is C. Okay, so D plus C is this line. Okay, this one you go home and draw. Okay, I just want to highlight this one. Shh. Treat the vectors like algebra, but you need to draw the braces. So if you are asked to add vectors, you add them like algebra. So this is 2a plus 2b minus 9a plus 3b. This person not keen on learning one. Okay, so you expand, remove the bracket, and then you end up having 5b minus 7a. So this is the vector solution. So you can treat this like algebra, but remember your curly tail. If you don't put in your curly tail, then you will lose the answer mark. So this one, I believe you can also go home and do. Okay, let me thicken my pencil. Sometimes it's thick, sometimes it's not. I don't know what happened. Okay, minus 2 times 2u is minus 4u. So remember to put the curly tail, and then I just copy this over. 4v plus 3u. So treat it as algebra. 4v minus 6v is minus 2v. 3u minus u is minus u. So this is just the answer. So the only difference between this and algebra is there's a curly tail. Okay, the top one, they all copy the last time. Okay, you can draw the top one first. This one is just telling you the direction. O-level will never ask you to draw. In fact, they have never asked you to draw before. But it is to help you see the direction. So you can draw the top first.
Is it even in O-level?
No.
So why not?
No, this one drawing not in O-level, but you need to know how to read direction. So C is diagonal, right, of one rectangle. So when they have 2C, you have 2 rectangles. Can you see that? When you have 2C, you have 2 rectangles like that. So you just follow how they draw. Yeah.
Why your IV got extra?
IV?
Got extra 2 square? Why you color like that?
No, because 1C is like that.
Yeah.
2C is 2 of it.
Yeah.
Yeah lah.
Or you just color for fun?
I double it. Yeah, I color it so that you can see the rectangle. Why you all chanting? Okay, so C, we copy the 5L with the curly tail. Trust me, some of you forget the curly tail or the braces. Okay, this one is 10N. Okay, the negative 3, you apply to all 3 terms here. So you should end up with minus 6L, minus 3M, and plus 6N. So the sign is very important. Make sure y'all don't be careless. So the algebra is 5L minus 6L is minus L. Okay. Then 5M minus 3M is plus 2M. Okay, last one is 10N and 6N. So 16N. So these 3. So final answer is still working like algebra. Just make sure you put the curly tail.
I want a cat one.
Shh. Yes.
What's
What's the
the cat?
what? Yeah, I haven't thought about. Actually, I got lollipop, but if I give you all lollipop, you all eat too long. I must. Today I can buy. Because today I need to go Tampines Mall. Okay, yeah. Okay, AB, they tell you is represented by vector A. So you just change only. Then I have DC. So DC is in opposite direction. So change it to B, minus B. That's all. So when there's a reverse in direction, if CD is B, then DC is negative B. Change in direction, you reverse it. Okay, so this one next thing, 2AB. So the AB I change to A. Another AB here, change to A. There's a BA here. So you need to put in negative A. So that's the only thing when the direction change at a negative sign. So total, total there's 6 A's. Okay, quite okay, huh? Okay, last one is C. To move from C and then move back from D to C, you are going back to the original point. So let's see this one. This is B, right? Moving from C to D is B. Moving from D to C is negative B. Can you see that they become nothing? So you don't write 0, you write 0 with the vector. So it means it goes back to the original point. Which makes sense, you go from C to D, then you come back. So that's why you are back to the original point. So not equals to 0, but equal to the 0 vector.
Is
Yes.
that O or 0? Why you write the O?
0 with this tells you that it's 0, 0. It is not like 0. It is the vector 0. So you must write the curly tail. Yes. Yeah, so this one I can plus minus, but that means I need to simplify one step lah. Then after that write A minus B. Okay, I hope Brennan and Krishvan pair is working out.
I'm dead. I didn't sleep last night.
You didn't sleep last night. I hear a bit of your emotions. So try to catch up on this sleep.
Who does she know?
You see, they look like they teaching each other, meh? So much joy. They studying, meh? Okay, yes. Okay, I move on, Next concept is on parallel vector. Parallel vector. So if I say two vectors are parallel, they are a ratio of each other. For example, I give you an example. If I say A is 1, 2. Okay, if I say A is the vector 1, 2, it means that this vector A is moving in the x direction 1 unit, moving in the y direction 2 units. So the vector A represents 1, 2. Okay, then I have another vector B. I say it's 2, 4. So it means if I draw the vector B, it is 2 units in the x direction and 4 units in the y direction. So what they are trying to tell me is, if I can express B as a ratio of A, then they must be parallel. That means these two vectors must be parallel to each other. So actually, right, we all can see that B is, you take out the 2, this one become 1, 2, right? Like matrices like that, you can multiply one, right? So you take out the 2, it is actually 2 times of A. So if I can show that vector B is a ratio of vector A, they must be parallel to each other. Then I can conclude B is parallel to A, which you can see from the 2 green arrows, they are parallel to each other because the triangle they form are proportional. So this whole sentence here, like some alien language, just means that if I have 2 vectors and I can express them as a multiple of each other, they are parallel. Yeah, K is any constant number lah. So in this case, I found out that it's 2. But it can represent any constant number. Can I? So if I say 3 points are collinear, collinear means lie on the same line. So if I have 3 points, A, B, C, all lie on the same line, I call them collinear points. Collinear points. So when they are collinear, they must be parallel to each other. That means AB is parallel to BC is parallel to AC. Can see that? AB parallel to BC parallel to AC. That's why I can write them to be ratio of each other. Okay? So these 2 paragraphs just telling you these things that I'm telling you now. You were sleeping. Yeah. So as I teach, you try to understand. I waked you. I tried. Yeah? Wait. I bring a cane. I have 2 at home.
Yes.
One for my son, another one still for my son.
Why you cane your son?
I threatened to cane him, but he's not even scared. He offered me his leg.
Because you never actually hit that. You must actually hit that.
Okay, next one. If AB is 2A plus B, that means they tell me this. 2A plus B. Okay, and it is parallel to CD. So just now we mentioned that if they are parallel, we can say that they are ratios of each other. So I can write this. AB is equal to K times of CD. Just now, above, they tell us already, right? If they are parallel, I can write that they are a ratio of each other. So I just plug in now. This is my AB. I write it as 2A plus B. Okay, and then CD, they say is 3A plus PB. Okay, notice the difference. The K here is an algebra, right? It's a constant number. P here is also an algebra. The rest are vectors. So your curly tail differentiates from the algebra. So you have to put the curly tail at the right place. Okay, if they are equal, it means I can compare them. So I expand this one becomes 3KA. If I expand this one becomes PKB. Ayo, why my pencil suddenly become thin? Sometimes it's the tip, is it?
It's the pressure.
Is it? I put the same pressure, what? I zoom in, then become like that. Oh yeah.
I got like that one.
Yeah, first time I know. Okay. So what happens now is I want to do an apple and apple comparison. So 2 must be equal to 3K. The 1 here must be equals to PK. So if I compare them, since they are equal, it tells me that 2 is 3K, so K is 2/3. The second comparison I make is this. This is 1, right? So 1 is equal to pk, and I already know k is 2/3. So I sub k as 2/3. Then p is just 1 divided by 2/3, which is 3/2. So this is how you solve. So you just compare each of them accordingly. Silesh, following? Okay? So when they are parallel, you must write this. They are ratio of each other. That means it is k times of the other vector. And then you just expand in and compare. Okay, but when they say they are equal, that means they are not a ratio of each other. You can change to any other letter you like. A to Z, up to you to choose. I can only multiply k into this, yeah. Because it's k times of it. It's just like just now, when I say it's 2 times of it, I multiply the 2 inside the 2 term. Which one is the what? It doesn't matter, because the k, if it's smaller, it will become half, 1/3. The k will become a smaller number. Yeah, if it's a bigger number, it will be more than 1. If it's smaller, it will become fraction. That's why this one is fraction. Yeah. Can I? Okay, what if they are equal? When they are equal, it's very easy. You can compare them directly. So AB is equal to CD, means 5A plus 6B must be equal to HA plus KB. That means I don't even need to multiply by a multiple. I can compare them already. This one is H. So H is 5. And then this one is 6 because they are equal. Done. Okay, so when they are equal, you can start to compare them already. Don't even need to multiply by a constant. Yeah. Because they are equal, they are not parallel.
Can you move your question 1 to
Question 1 to what?
question 1? You know, I look away for 5 seconds and there's a whole essay on the damn straight.
Like that.
You can move it.
Question 1.
Next question.
Yeah. Yes. There's nothing to expand. They say AB is just 5A plus 6B, so I just replace only. This is my AB. The other one I need to expand because I want to compare them. So I need to expand my K into 3A and my K into PB. Then I can compare the left side with the left side, the right side with the right side. I must simplify first, then I can compare. So this is, the number in front of B is 1. I compare with PK. Because this is the number in front of B. Yeah. So you are just comparing the coefficient. A and B is like a column matrix that they never tell you what it is. So A actually represents some matrix, but they don't want to tell you what it is. So you just leave it as A. Yeah. Okay, last one. Shh. This one, example 3, they already tell you they are equal. So they are asking you to compare this with this. Latika, noisy. So 2K you compare with 6 because they are equal. So 2K must be equal to 6. K must be 3. Okay, then this one, you compare with this. So 1 minus H is -3. So if you try to solve for H, it is 1 plus 3, which is 4. So this one, they are equal, you can straight away compare. Which B? Sorry? Why? I never leave that out. I compare this with this what? They are equal.
Minus h is negative 3.
Then this one, I compare this with this. Because they are equal, these two numbers must be the same. I think some parts of it we need to learn after WA. I don't think we can finish before. Okay, shh. Now they give you two vectors and they ask you to tell them about the relationship between AB and CD. Are they equal? They are not equal for sure, right? Because this is 2A plus B. This is 4A plus 2B. Are they a ratio of each other? Yes, right? So for CD, I realize I can take out the common factor 2. Okay, for this one, I realize I can take out the common factor 2. And then this is actually my AB. So what I've realized is actually CD is 2 times of AB. Okay, when you can prove that it is proportional to it, then you can conclude. Since CD is twice of AB, therefore CD is parallel to AB. That's all. What you can say about it is that they are parallel. So if they are proportional, they are parallel. If they are equal, then everything must be exactly the same. If they are proportional, they are parallel. If they are equal, everything must be the same. It's a ratio of each other. Like this one is 2 times of it. So if you can express this as how many times of the other one, yes. Exactly the same. Everything is the same. How many times of it? Yes. Yeah. Okay, 3 minutes. Breather. 3 minutes breather. Like breathe. How long? 20 minutes, 35. I need one period. Actually, just nice.
Also BK.
Which one BK? Can. So that means I put the K here, then I don't expand this. I expand this. Also can. That means you will write CD is K times of AB. Then you expand here and
I ask my
compare. Also
grandparents
can.
bring food for me, why?
Student, stop
Yes.
the cheat codes.
What?
Sure, so
That's cheating.
how come this parallel not collinear?
If they share one point in common, that means if let's say this is B, C and
But what
AB,
is hyphen?
the B is common, right? Then it's collinear.
Vegetable, right?
So okay, see this one parallel I prove already, right? But they don't share any common points. So they are 2 separate lines. So I cannot say they're collinear. But if this is AB and this is BC, got 1 point same, right? They are not just parallel, they are the same line.
So what can you explain collinear?
Oh, like, okay, you see, give me. So if I give you like AB is A plus B. Then I give you BC is 2A plus 2B.
Okay.
And I know that this is 2 times of AB, right?
Yeah?
Then I will say BC must be parallel to AB lah.
Yeah.
Okay, because they share one common point,
What's the common?
B.
Oh, okay.
So the B must be together. The B must be together. So since they share
Do a trade.
common point B,
They're collinear.
yeah,
Oh, so this one got no common point.
yeah, no common point, so they must be separate line.
This one also got ratio.
Yes, so they are parallel only.
So
Collinear depends on the letter.
Yes. If there's one that is the same, then they are same. If not, if they just parallel, won't meet each other. Yeah, nah. They must have a common friend. Yeah, your pen. That's weird.
I don't understand how.
You see, this one 5A equal to HA. They are equal, so the 5 must be equal to H. This one 6B, this one KB. So because they are equal,
Only when they say it's equal.
yeah, then you can compare the A with the A, the B with the B. You see the B with the B. So K must be 6. H must be 5. If not, how to be equal?
So only if it's same then.
You can start comparing.
So like this is not.
Also same, equal. When they are equal, that means the 2K must be equal to 6. The 1 minus H must be equal to minus 3. Because they are exactly the same, so these two must be the same. These two must be the same. Yes.
Yeah. Is this correct?
Is 2 times of xy, so they are parallel. Yeah. Oh, okay, then one more thing. Because they share a common point x, they must be collinear also. Not just parallel, but because they share the common point x, right? So 2 parallel lines got 1 x in common. So they must be the same line.
So they're equal.
No, not equal. When you have 2 parallel lines, right? Originally it's like that. But because this one got x, this one also got x, the x must be together, ma. So this parallel line must be together, means the 3 point must be the same line. That means actually this 3-point line on the same line. So if you can show to me that there's a common point, you have one more thing to say about them is they are collinear points. So it says since they share a common point x, x, y, and w are collinear points. One more statement.
X, Y, and
W are collinear points. So this one is correct already. Just one more. Since they share common point x, x, y, and w, they are collinear points. One more step. Yeah. So you can say 2 things about them, not just one.
No, this one is interchangeable.
Yes.
Okay. Thank you.
Yeah.
So right.
Mm.
Is it 2A equals 6A? Because there's no constant.
No, they never say it's equal, right? They are not equal, right? Can you find that they are proportional?
Yeah.
So BC is how many times of AB?
3.
Yeah, true.
So they are parallel.
This one.
Yes.
How to show the equation?
AB is BC is 3 times
yeah,
of
yeah,
AB.
I wrote wrong.
Then therefore AB is parallel to BC.
Don't you show equation?
If you want can. If you can see, no need.
Okay.
Yeah. Okay, come back. I gave you 5 accidentally. Last 3. Then maybe we can do the test. Okay, it should be in your mind already. All the data analysis, all the probability. Not much formula to memorize. Okay, let's look at example 5. One look at it, you know they are not equal. In fact, if you compare BC and AB, they are proportional to each other. Can you see that BC, I can take out the common factor 3. And then I have a 2A plus B. So this 2A plus B is actually my AB. So I put in my AB. So I've proven that BC is 3 times of AB. Therefore, BC is parallel to AB. Since BC is 3 times of AB. So this is one thing you can say about it. Okay, but just to bring to your attention, can you see that they share a common point? Common point B. So which means to say, BC is this line here. BC. Okay, BC is here. This is the direction. Then I have another line, AB. Here. Let me use highlighter. AB here. This length or the proportion of it is 3 times the red line. The black line is 3 times of the red line. But because they share a common point B, this point cannot appear at 2 different places, right? It's not like you can superimpose or you just, I don't know, teleport from one point to the other. These 2 points must lie at the same place, right? So actually what happened is this part here. Can I shift? Can I shift this? Okay, never mind. This thing here that you see should actually be here. Because the B is the same point B in that common space. So actually, can you see that this A, B, C, they are lying on the same space, on the same line? So you can comment one more thing. Okay, since they share a common point, B, then you can conclude that points A, B, C are collinear points. So you can comment two things. If you comment only one part, you lose one final mark lah on this comment. So when you observe that the parallel lines got something in common between them, that means they share one common point, then you can add on to tell me they must lie on the same line. These 3 points must lie on the same straight line. These 3 points. Okay? So this is the important part. Jamil, you focusing. Keep looking at the screen. Okay, next one. XW. If you observe carefully, I can take out the common factor 2. So actually it's 2 times of XY.
Why they collinear?
Because they share a common point B, they must overlap. They must be actually the same line. The B must converge with the other B. They cannot be 2 separate lines on the space. No, it's like this is BC and this is AB. I say that this line is 3 times of this line. That's why they are parallel. But they both stem from B. So there cannot be 2 separate lines. They must be on the same line because B must be that same point. So these 2 points must join together.
So it is the starting and the ending.
If there is one point that they share in common, that means they must stick together. The parallel line is the same line. Okay? So that's the key. Same thing here. I've proven that XW is parallel to XY since they are proportional to each other, or we say they are scalar multiple of each other. Scalar multiple of each other. This is another word for proportional. Why scalar? Scalar is the constant K. That means you can find a constant number that is a multiple of the other vector. Okay, these are just some mathematical terms they like to use, but when you hear it, don't be scared. It just means they are proportional. Okay, so one other conclusion I can make is that since they share the common point X, okay, therefore, points W, X, and Y are collinear points. But if they don't share, then they are just parallel. They have nothing else in common. Okay? So, like just now, we have A, B, and C, D. Now, no common point, so they are not collinear. They are just parallel. So, it just so happened that all these share a common point. That's why you can say they are collinear. These two, then now you know they don't share anything in common. So even they are proportional, they cannot be collinear. Yeah, X is in the middle. It doesn't matter actually, you see your XW is here. Then you can have a XY. Your XY is XY is here. That means actually it's a midpoint. Yeah, so Y is just in the middle of it. This is 2 times, right? This is 2 times. So your Y happens to be in the middle of the line, midpoint.
So as long as there's 2 multiple ones, it's collinear.
If they share a common point, then you can say collinear.
Yeah, that's so multiple.
Yes. Okay, next, between PQ and RS, is there something in common between them? Have. You see RS, I take out half, left with A.
I thought you asked me about collinear. Yeah, okay.
Okay, so this one is 4.
I thought it's times 2.
You can times 2 also if you prefer that. Okay, so if you want to work the other way, you can do a 2RS. If you multiply this by 2, also can, 2 ways of looking at this. This one become A plus 4B. So actually 2RS is equal to PQ. Also can. Or if you have seen it in this way, then it's half of PQ. These two are the same. These two are equivalent. You either prove this one or this one. Either one, no need to show both. See what is more comfortable for you. So either case, whether it's half of PQ or whether PQ is twice of RS, you can conclude that RS is parallel to PQ. Okay? But you cannot say they are collinear because they have no common point. PQRS, 4 different points. So that's all you can say. You cannot say anything else. So this one is a common question that O-level like to ask. They will ask you to make 2 comments about the vectors. Or just make comments about the vectors. Then you just have to tell them. Usually it's parallel, not parallel. Collinear, not collinear. Okay, that's it for this part.